Okay, we'll be doing 7D and number 8 of 11.4A Maths for this particular video. Remember we learned about the double angle in the previous two lessons. So you have the double angle for sine, double angle for cosine, double angle for tangent, and we mentioned that double angle for cosine, right? There are three different variations. It can be this one, or this one. They are all equivalent to cosine 2a. Okay, and the reason why we call it double angle is that this angle here on the right is double that of the angle here. Alright, similarly for all the rest. Okay, so you're supposed to, for question 7D in your textbook, right, prove that this is equals to this. Okay, now let us see how we can do it. Actually, if you look at this whole expression, the right hand side looks more complicated, right? So actually should start from the right hand side, but I will try to do from the left hand side. Can you see that this sine square x over 2, okay, the argument here is x over 2. Argument is the so-called the angle inside the sine. Okay, so can you see that this is not here, it's not here, it's not the sine, it's not the tangent, it is, you can say that it's here, but we don't want to use this because this will actually complicate the whole thing, because you will later get cosine square a over 2 and then cosine a, which is actually going to complicate everything. So I'm going to use this one. Okay, that means this is equals to this, correct? So if I let my a be x over 2, then this will be 2 times of this x over 2, so it's cos x, correct? Okay, I will just write this here. So cos x is equals to 1 minus 2 sine square x over 2. Okay, and this sine square x over 2 is exactly what I want. Okay, so if I were to do a little bit of manipulation, I will have okay, yeah, so you can do this side working here, and then your this left hand side, which is this one, you can write it as 1 minus cos x over 2. Okay, now this is very far from what we have here, right? First glance, yes, it does look very far away from whatever we have there. But if I were to now, because I want, you see, I already have the 2 there. I have the 2 here, right? Okay, so if I multiply tangent to the denominator, I would actually have the denominator 2 tangent x, which is exactly what I want. Okay, so for the next step, I'm going to do this. I'm going to multiply the denominator by tangent x, and that will give me this. But I cannot just multiply the denominator by tangent x, because that will make this second line not equal to this third line, right? So if I want to multiply by tangent x here, I must multiply this whole thing, and I need to put bracket. That's why I put bracket just now, by tangent x. Okay, now you know that the denominator is just 2 tangent x, and that's what we want. Now the numerator, if I just expand it, right, I'll get tangent x minus cos x tangent x, correct? But tangent x is actually sine over cosine, right? You see, I've gotten this, I've gotten this. Now the only thing is this Okay, so I need to do something to this in order to make it become sine x, and you know that tangent x is sine over cosine. So I'm going to just do that. Change this to sine over cosine. And that will give me, don't change the rest, all these don't change, okay? Because it's already what you want. Alright? Okay, then this will give me, sorry I missed out x here, minus sine x, right? Yeah, so that's all for this particular question. Okay? Yeah, alright. Now, if I don't start from the left hand side, okay, if I were to start from the right hand side now, how would it look? Okay, let me erase this. Okay, so you see how powerful the double angle formula is to help you solve this kind of questions. Okay, now if I were to start from the right hand side, now right hand side is made up of tangent x minus sine x over 2 tangent x, and I noticed that ultimately I only want sine square x over 2, which means that I don't want tangent, I don't want cosine. So I have to do something to this tangent, and I know that tangent is sine over cosine. Okay, so I write it as such. Okay, this one also same, sine over cosine. Now this 2 I can actually write here because 2 is actually 2 over 1, so it belongs to the numerator. Okay, now sine, you must also notice that sine is actually sine over 1. Okay, now if I want to simplify this, right, okay, I can make the numerator, which is the thing that the expressions that I've just bracketed up, I can take this and change it into a single fraction. Now how do I do that? Remember, I need to times cosine here, times cosine here, cosine, cosine. So that will give me sine x cosine x, right? Now this is only the numerator, okay? This part here, the one with the bracket. Okay, now my denominator, I leave it as it is. Okay, writing the 2 at the numerator, alright? Okay, now the good thing about writing fraction, a single fraction divided by a single fraction, is that it's actually this fraction divided by this fraction. So when you divide, you flip, right? You flip. Okay, so when you flip, what do you get? You actually get this. Times flip, this one flip, so the 2 sine x go to the bottom, right? And the cosine x flip to the top. Okay, this will allow you to cancel these 2 and you end up with this, right? Okay, now this is nowhere near what we want, alright? But I noticed that there's a sign here, sign here, sign here, right? So I take out common factor. Okay, then again I can cancel, and I would have 1 minus cos x over 2. Now 1 minus cos, okay, I rewrite here. 1 minus cos x over 2 is actually this fella just now. Okay, remember? Remember just now we said that this one is 1 minus 2 sine square x over 2. Okay, and then this one is cosine x, right? Okay, so if I take 1, then this fella bring over 1 minus cos, there, 1 minus cos, then I divide by 2, right? Yeah, that isn't it, this one. Okay, so that's how you get your left hand side. Yeah, so that's the other way to prove it. So you can do it whichever way you're more comfortable with. Okay, so that's number 7D. Now let's go to the last question for this video. You're asked to prove this. Now, whenever you see something like that, now this can be, I hope you can see immediately that this is a perfect square, difference of two squares. Okay, so if you don't know what I mean, I can write this as sine square x square, correct? Sine square x, you square it, is sine power 4x, right? Then minus is still minus here, this minus here. Similarly, I can write the same for this. Okay, and let me say that I'm doing from the left hand side. Okay, I'm trying to prove this equals to this, alright? Okay, then plus 3. Okay, now once you have this, a square minus b square, right? Then it will be, I hope you can see the pattern. This is like your a square minus b square. So this is your a, right? This is your b, this is your a, this is your b. Okay, and one is plus, one is minus, right? I hope you still remember. Okay, now isn't this equals to 1? Okay, and isn't this equals to sine square x minus cos square x? Isn't it equals to this? Your double angle here, there, cos square a minus sine square a is cos 2a, right? So it's actually cos 2x there, here. Alright, okay, so then you say not the same. Yeah, sorry, not the same. Why not the same? Because this is cos square x minus sine square x. This is sine square x minus cos square x. So I should put a minus here, right? Now they are the same already, right? Okay, so minus cos 2x times this is just minus cos 2x plus 3, which is the same as this. Okay, so it's equals to the right hand side. Alright, so we've proven the first part already. Now I hope by now you're familiar and clear about how to use the double angle, and from the previous lessons how to use the addition formula. Okay, now once you have proven this, now in the O level or in our exam, right, they like to first part ask you to prove something, then second part using what you have proved, right, to solve something. This is solving Okay, so let me erase this. Now, do you still remember how to solve trigo equations? Now this is trigonometry, right? That's an equation here. So this is solving trigo equations, right? Hope you still remember we use AddMath to help us to solve trigo equations. So that's what I'm going to do here. AddMath. Okay, firstly, you must get the equivalent form. That's what the E means. That means you must get sine, cosine, or tangent of something equals to some number. Okay, so is it sine or cosine or tangent or something equal to some number already? No, not yet. Okay, that's why they use the word hence here. They want you to use this first part to help you. Now, do you notice that this is exactly the same as, actually not exactly the same, it's partly the same. We have this, but we need another plus 3. So how? Okay, so what you do is like that. Now we don't have the plus 3 here, right? We only have, okay, let me erase all this. We only have this whole part here, okay, without the plus 3, right? So what I'm going to do is I'm going to plus 3 to both sides. Why like that? So that I can replace this whole thing with this whole thing. Then you ask me why like that? Why you want to do that? Because to have power 4 is very hard to solve. Very, very difficult to solve. So we want to avoid that. Okay? So we go to a trigo ratio without the power. Okay, already there's a power here. Alright? We try to get rid of it later. Okay? So now how do we do the question? Okay. What we need to do now is we plus 3 this side, right? So we must plus 3 on the other side. So I get 5 lah. 2 plus 3 is 5, right? So this is 5. And this whole thing, okay, this whole thing will be 3 minus cos 2x plus 2 sine square x. Okay? Then you ask me, ayo, like that how to solve? Very complicated, right? Okay, so now can you see that this cosine 2x here we can actually replace it with either this, or this. Can see that? Okay? And because our friend here is sine square x, alright, so we will use this. They ask me why. Okay, you see we already said equivalent form, we want it either sine, cosine or tangent only, right? But now you see you have cosine and sine. Then it complicates the whole thing, you see. So that's the reason why I want you to use AddMath to help you. This AddMath, this E, right, helps you to realize that you need to either get sine, cosine or tangent. But now you got cosine 2x and sine square x. So very cannot solve. Okay, so you need to replace this with sine square x. Okay, I show you what I mean. So this will be 3 minus this cos 2x is actually 1 minus 2 sine square x, right? Then plus 2 sine square x equals to 5. Am I correct? Now everything is in terms of sine square x. Can you see that? Okay, I'm going to open up the brackets. Okay, then I'm going to group all the sine square x whatever together. Hey, I'm still doing E, you know. I'm still doing E, the AddMath E, because I've not gotten the sine alone yet, you see. Yeah, so like that. Okay, now I can isolate this sine square, and then I square root both sides. I will get now finally I square root both sides. Finally, after a lot of hard work, I've gotten plus minus square root 3 over 2. Yeah. Now what does this mean? Okay, it means that I finally reached the AddMath, the E. I've gotten this part already. Done. Okay? Now I go to the next one. Domain, right? Domain. Domain means from what to what angle. So x is between 0 to pi, right? X is between 0 to pi. Oh, no equal, sorry. If there's equal, they will say inclusive, okay? There's no equal, 0 to 2 pi, okay? So this one nothing, no need to change because this is x, this one is x also. Now mode. What mode must you be in? Your calculator must be in the radian mode. Why radian? Because this is in radians. How do you know this is in radians? Because there's no degree symbol. Okay, so this is radian mode. Change your calculator mode to radian now. Okay, the first A is your alpha. The second one is ASTC. You see alphabetical order L, M, N, O, P, Q, R, S. So alpha comes first, right? So you look for your alpha. How to find the alpha? Very simple. Ignore the negative sign. Okay? Your alpha, you just sign inverse of square root 3 over 2. Okay? You should know the answer. You should know the answer. But okay, let's say you don't know. you change to radian mode. This radian mode already, right? Okay, can you see the radian mode? Okay, then you inverse sine square root 3 then over 2. Then you get this. Then what is this? Okay, you know that actually this is a special angle. Alright? So you divide by pi to see exactly how many pi's that number was made up of. Oh, so it's 1/3 pi. That means it's pi over 3 lah. Pi over 3. So your alpha is pi over 3. Okay, we're done. We're done. Wait we're done this already, right? Now we're going to do ASTC. Now, the very fact that sine can be positive or negative means that all the quadrant also can. The answer can be found in all the quadrants. So your x, this is the final answer already, okay? Your x can be pi over 3, okay? Okay, all these are pi over 3, Let me just shade the reference angle. Okay, so it is pi over 3. What angle is this? This is pi over 3, right? This is pi over 3. This whole thing is pi, So, wait, Aiyo. 180, which is pi, minus pi over 3. That's your second answer. Then, this is pi over 3, right? Here is pi over 3, Down here is pi plus pi over 3, Okay? And finally, this angle here. Yeah, this is pi over 3 also, right? This shaded angle here. So isn't it 2 pi minus pi over 3? Then you're going to get the answer, So the answer is pi over 3. 2 pi over 3. This is 4 pi over 3. And this is 5 pi over 3. So that's your answer already. Okay? So that's the end of this. We haven't end yet. ASTC done already. I just want you to check that your answer falls within the domain that's given to you. They say x is between 0 to 2 pi, right? Is your final answer between 0 to 2 pi? Yes. Yes, then that's your final answer, Okay? So that's all,